So we have a balanced ABC circuit with a Vn value of 100 phasor 10 degrees, and it's connected to a delta connected balance load. So pretty much our thing looks something like this. So the load, instead of being a Y load, it's actually a delta load. So it looks something like this. Something like that. Okay, this is a delta load, and pretty much we need to find the phasor voltage. Calculate the phase. Sorry, calculate the phase and line currents. Not there's no sorry. There's no phasor voltage. Okay, so calculate the phase and line currents. So pretty much to calculate, so we can easily calculate the line current. Okay, but to calculate that, we have to convert this from delta to Y transformation. So this is how we can do it. So recall line currents. So A uh, IAN, IBN. Okay, let's just stick with IAN. It's equal to VAN all over ZY. Okay, so right now we have Z delta, which is 8 plus 4j. To convert it to ZY, it's actually equal to Z delta all over 3. So we just have to divide this by 3. So 8 over 3 plus 4 over 3j is equal to ZY. And that is just 2.981 phasor 26.57 degrees. Okay, so we have that down, so that's good. Now let's see what we need to find next. Oh yeah, and we're not going to do like minus 120 for this one, okay? So don't do it for impedance value. So we have ZY, so that's done. Now we also have VAN, so that's another thing down. So IAN is equal to 100 phasor 10 degrees all over 2.981 phasor 26.57 degrees. So that's just, give me a sec. That's 33.57 phasor minus 16.57 amperes. Now, IBN, since we're told it's an ABC sequence circuit, what we just do is subtract minus 120. So that's 33.53 phasor minus 136.57 degrees in amperes, and then IBN. We just do minus 120, and then we can add 360 at the end if we want to. Okay, so that's done. Now we have to find I. So pretty much we found the line current, which is the current passing through here. Now there's something called the phase current. Phase current is pretty much the current passing through here. So what we can do is there's actually a formula for this. So if we have an ABC circuit, VAN will be equal to VAB all over the square root of 3 phasor minus 30, and then IAB is equal to IAN all over the square root of 3 phasor positive 30 degrees. And then this is for ABC. If it's ACB, we just flip these two signs. So just flip these two, and that's ACB. So right now we have to find IAB. So we just use this formula. So IAB will be equal to 33.57 all over the square root of 3 phasor minus 16.57 plus 30 degrees. So that gives me 19.38 phasor 13.43. That's IAB. IBC. Okay, so we just subtract minus 120 from this. that's phasor minus 106.57 degrees, and then I, ZA, again, subtract 120, and then you can add 30 at the end, 130 at the end, and that's 133.43, and all of these are in amperes, okay? So these are your final answers.